A reflection is a kind of transformation. It is basically a flip of a shape over a line of reflection. What you need to know is that that line of reflection can be anywhere. In our example, we're going to use x equals 2. It could be an axis, or it could be a different line. But the idea is that your points should be equal distance from that line, but on the opposite side. In this example, we're going to reflect across x equals 2. So we take our point, x equals 2, and move all the way up the graph and all the way down the graph. That line represents every ordered pair where x has a value of 2. Now our triangle on the left side, ABC, is going to be reflected across that line, and it will be on the right side when we're done as a mirror image. So basically we can fold it on the line of reflection and it should meet up exactly. To do this, we'll take each point, count the distance to the line, and then continue counting that many spaces in the opposite direction. We'll do that for every point, and then we'll connect our points, and we'll have our transformed triangle A prime, B prime, and C prime. A translation simply means you moved an item. We translate stuff all the time. You don't change its size, you don't rotate it, you don't do anything else. You just move it. Now on a coordinate plane, that means you move each point the same distance and in the same direction. In this example, we're going to translate our trapezoid ABCD, 4 points to the left and 6 points down. Now on your graph, that simply means you take each point, you move it 4 points to the left, you move it 6 points down, and you have your new point. So we do that for all 4 of the vertices of our trapezoid. If we're looking at the ordered pairs, we can use operations instead of having to use a graph. So for instance, point A was at 3, 6. If we move 4 points to the left, our x value will decrease by 4 because we moved left. So we can take our x value of 3 and subtract 4, as seen in the black, and that gives us our new ordered pair of -1 for the x value. Now for the y value, we went 6 down. So since we went down 6, we're going to subtract 6 from our y value. So we take our ordered pair, 3, 6, our y value is 6, 6 minus 6 is 0. So A prime is at -1, 0. A dilation is a type of transformation that changes the size of the image. The scale factor measures how much larger or smaller the image is. If you remember back to when we talked about proportionality, a scale factor greater than 1 will cause an object to be larger, where a scale factor less than 1 will decrease the size of the object. Now on a coordinate plane, you must apply that scale factor to both the x and y coordinates for each ordered pair that you have. In this example, we're going to apply a scale factor of 2 to our trapezoid. We have the ordered pairs for all 4 vertices, A, B, C, and D. And what we'll do is we'll take both the x and y values for each ordered pair, and we will apply the scale factor to each part. So for point A at -1, 1, we apply the scale factor of 2, so we have -1 times 2 for x and 1 times 2 for y. That gives us an A prime at -2, 2. Now once we've done this to all 4 of the vertices, we can plot our new ordered pairs, and you can see that the new trapezoid is larger than the original one. Of course, it should be larger because we used a scale factor greater than 1. Now you'll see in an upcoming unit that it's actually 4 times larger in area. I know that's a little confusing, but if you think about it, we didn't use the 2 once, we actually used it twice for both x and y, so it's really 4 times larger.